Okay, I'm going to show you how to use the TI-84 calculator to evaluate normal distributions. Cumulative SAT scores are approximated well by a normal model with mean of 1500, standard deviation of 300. Part A. What is the probability that a randomly selected SAT taker scores between 900 and 1100 on the SAT? Before we even use the calculator, I highly recommend that we draw out a curve. So here's a curve drawn and labeled, and let's go ahead and shade. Okay, now we use the calculator. Even seasoned statisticians do this, so I recommend you do it. I know we're in a section on how to use technology, but I really cannot emphasize this enough. Don't just use the calculator on these. This one was pretty easy. You probably could have done it, but I highly recommend you draw these out, label, and shade. Okay, so we're going to access the normal distribution by going to second vars. And we're going to do normal CDF. You don't really use the PDF unless we're going to put it in the graph. So the CDF, number 2. Now if you have the stat wizard, you're going to go to the lower bound, which is 900. Upper bound was 1100. The mean was 1500. And standard deviation of 300. If you don't have the stat wizard, when you put this in, it's left bound 900, right bound 1100, and then the mean 1500, and then the standard deviation 300. So left bound, right bound, mean, standard deviation. Remember that syntax. And press enter. So our probability is about 0.068. Part B, what is the probability that a randomly selected SAT taker scores at least 1650 on the SAT? Again, we're going to draw, label, and shade the normal curve. Okay, once we've done that, I see what I'm going to do. I'm going to go to the vars to access distribution, number 2. The lower this time, since it says at least 1650, we know that's our least, that's our lower bound, 1650. Now the upper bound, we actually go out to infinity. You can put any really big number here. I always get in the habit of just saying 1e99. So this is 1 times 10 to the 99th. Again, our mean and standard deviation are the same as they were before, so they're still there. And press paste. And we get 0.309, rounded to 3 places. Okay, part C. What is the probability that a randomly selected SAT taker scores at most 1700 on the SAT? Again, draw this out. So at most means I'm going to be shading to the left. And let's access the distribution, number 2. So lower bound this time is actually going out to negative infinity. So I'm going to put negative 1e99. 1700. And the mean standard deviation 1500 and 300 respectively. Press paste and press enter. So about 0.748. It's almost 75%.